Right? All right, let's get going. I'm ready if you're ready. Ashley's ready. She's ready. Ashley's ready. I'm ready. Let's do it. I hope you enjoyed your day in here yesterday. You only get one of those. But I did get like 2 very important hours of work in between 6 and 7. So thank you guys for, for letting me give you the day off. That was nice. But we are going to get back after today. So take us somewhere right with something to write on. Let's jump right back into kind of where we left off on Friday, which was the last day where we did anything. And we were solving log equations. So you can just kind of continue your notes from there. We'll just do a handful or 2 together. Then you'll do a handful or 2 yourself. We'll kind of talk through the process, kind of reacclimate you with kind of making the switch back the other way. And that's why I left that up there over there. We're just going to go back, right? We're going to go from logs back to exponents. Variable stuck in an exponent, use log. Variable stuck in a log, let's use exponents. Calculator would probably come in handy today because, sometimes we're like taking cube roots or raising something to the 10th power and just don't want to do that stuff by hand. So have that out nearby so you get familiar with the buttons. Again, I left the calculator thing up there for logs, but if we're starting with a log, our answer is going to end as an exponent. And it could be a root, right? Exponents or roots, kind of depending if we're up at that level. And I think the thing that would work well for us is kind of like to almost redo what we did Friday so we see it again. And then I'll expand on it a little bit just as things maybe aren't ready for the switch or whatever. And then I'll give you, like I said, a handful or 2 to try at the end and probably end a little bit early because I can only do so much. But getting as far as we probably will today, and if you're comfortable with it today, then you'll be good to go tomorrow. What we'll probably do by tentative schedule for us for the rest of this week, of course, homeroom tomorrow, so a little shorter classes. That'll be probably the day where we do our first of 2 quizzes, right? A completion and effort one, just try your best. And just kind of a practice day, really. So I can put another grade in there. And then Thursday, we'll do one for real. And of course, it's, open notes and ask questions and all that kind of good stuff.
And we finished early on the first day. Can we start the real one, or should we just wait until
We'll just wait because we'll have more than enough time to do it Thursday, yeah. And then what we'll do Friday is like kind of what we did last week is we'll preview what's coming the next week. Seniors, that upcoming week will be your last week. And so we'll talk about what we want to do to get you guys wrapped up. What I'm going to do is I'm going to send a senior-wide Algebra 2 email out to let you guys know what's happening. Okay, so expect that next couple days.
Do they do graduation at the same place every year?
It's at Echo Park. It's at the stadium.
It is?
Yeah, it's at the football stadium. And graduation is the 20th. And so I don't know if you can see it, but right, we got this week, last week of April. And then first week of May, that's the last week for seniors, Monday, Tuesday, Wednesday, Thursday. So we'll probably do our senior final maybe like, whatever, one of these day or 2 is kind of depending on how long it is. Friday, seniors don't have any class. That's like the senior barbecue, that's powder puff, there's stuff going on that day. But everybody else, we have regular school on the 7th. We have a full week after that. And then Monday, Tuesday, 17th, 18th, those are the last 2 days of regular school. Okay, so if you're not a senior, you've got 1, 2, 3 and a half weeks left. Okay, final start on the 19th. Okay, first and second period, Monday morning, then you're off for the afternoon. Thursday's graduation, everybody's off. No school, okay? Just graduation on the 20th. Echo Park, I think it's 10 a.m., 9 or 10 a.m.
Why so early?
Because there's like 3 graduations every day for 2 weeks.
Oh.
Yeah. Almost every Douglas County school uses Echo Park for graduation.
I didn't know that.
Yeah, 2 or 3 graduations a day. Like 1 in the morning, 1 in the afternoon. 21st, we're back to our final schedule. So 1st and 2nd on the 19th, off on the 20th for graduation. 3rd and 4th, the morning of Friday the 21st. Then we have the weekend. So it's kind of nice. We have a day off in between here, then 2 days off after that. Monday the 24th, that'll be 5th and 6th. With one of those being your lunch. It's kind of nice. And then Tuesday, the 25th, which is the last day of school, that is when our final is going to be during 7th, right, 12, 7, 8 on that morning. Okay. I think grades are due the 26th, the next day. And that's that. The last day to submit late work is the last day of regular school, that Tuesday, the 18th. Okay. That is 3 weeks from today. Yeah.
Oh, you said for the final, it's just everything we've done this semester?
Just this semester. Okay. So it's going to be inverses, and then all of the exponential stuff that we've done. Growth and decay, compound interest, continuous compound interest, properties of exponents, solving exponentials and logs, all that kind of stuff. But it will be multiple choice. Yeah, and it'll be probably on Canvas. Just the easiest way for me to grade it quickly. So that's the plan. That's what I'm thinking. I don't know how much more will get done after this. I have like 80 different things I can teach you in like 5 minutes to do it in. So we'll see how that goes. But like there's properties of logs we could do. There's complex numbers we could do. I could do some trigs that you see it. I know it's not Algebra 2 trig, but hey, if anybody's going to teach a trig, it should be me. But let's finish this thing up this week. So if you haven't, open things back up so we can write some stuff down. What I think we did on Friday, I think that's going to work really well, kind of doing 2 problems side by side so that you can see how similar they are in their initial setups and the differences in how we'll solve them once we get there. Let's go log base 3 of x equals 2. And log base x of 3 equals 2. Same numbers, just in different spots. Okay. And I think the thing that's going to make this as easy for us as possible is to realize that if your variable is stuck in a log, let's just go back to exponents. Okay, let's make the switch back. Now we can't do that until the log's by itself, but we're good, right? Log base of n, cool, done, ready. Log base 3 of x, awesome, good to go. Like there's no like +5 or ×2 or a squared or anything like that. The log is by itself, so we can make the switch. Now, what I think might be helpful for those of us that like to, since we're in log Binet, we've got a b, an n, and an e. If we can figure out what those are, and again, maybe it's something you write down, maybe it's something you just look for in your mind, that's cool too. I like to put them in the order that they're written from left to right. We used to do b equals e equals then n equals because it was exponential and it went b, e, n from left to right. Now, because it's log Binet, I'm going to put b then n second, then e, because now I just have to say, oh, 3, x, and 2, the order that it's written. And if that bothers you and you want to go b, e, n, okay, just be careful where you put what.
Wait, why'd you switch it?
Because the order that the log is in goes b, then n, then e. And if I write it down just for my own like mind frame to make sure things are good, if I write them b, then n, then e, I just have to go like left to right. I don't have to worry about, oh, what goes where. Because like the first thing I'm ever going to ask you to do on a test or a quiz is to write this down.
Okay.
You always have it sitting there waiting for you. Now, if it's in the right order, Yeah, sure. Now, like I'm gonna go to here, right? So I have to switch the order once I do that. But I don't mess up the order here if I just go left to right. Now, maybe you don't like that. Maybe you're like, I'm always gonna write it in the Venn order. Like either I'm gonna start that way or I'm gonna end that way. Just be careful putting things in the right spot. Long story short, things have to switch. The order is gonna switch. You just gotta be careful. All right, so same thing over here, right? If I can figure out what the B is, what the N is, and what the E is, again, I like to do it in that order because then it's just left to right. Then I'll make the switch. Base is X, argument is 3, exponent is 2. And I don't know, with exponential functions or whatever, equations, the variable is always an exponent. There's no other place you could go. With logs, there's two different spots, right? It could be the argument or it could be the base. And even though it's the same numbers, we're going to see that when we write it base, exponent, and then equal to the argument, well, things are now switched up, right? Okay, base here is 3. Cool. The exponent's 2. And then n is x. And remember, all I want to do is get to x equals. If I can get an answer, x equals some number, then I'm good to go. But look at your setup, right? This is kind of like, for me, like this is where the problem like kind of like restarts. Oh, and now I got an equation I can solve. I don't know how to solve this one, but I can solve this one. The x is already by itself. I don't have to like square or square root or add 7 or minus 5 or divide by 4 or whatever. Like it's already x equals. But it's equal to 3 squared. Well, what is that? 9. Then don't write 3 squared, write 9. Okay? Write one number rather than 2. You don't want to leave your answer, hey, x equals 2 plus 1. No, x equals 3, right? You never leave it as 2 plus 1. We'd always put those together. Same thing here. Okay? And even though this problem had 3x and 2, this one has the same thing, just in a different order. When we write it, base to the exponent equals the argument. When your variable is stuck in the base, your work's just not done yet. We're not solved for x yet. Like in my mind, like the problem like restarts right there underneath that squiggly line. Like I can't solve exponential function or log function, I don't know. But once I break the x out of the log and I get it into a form that doesn't have any logs in it, now I can start moving some stuff around. This one I didn't have to, I just had to rewrite 3 squared to make it nice. But this, we're not there yet, right? I'm not at x equals just yet. But we can get there. What do we need to do if we've got x squared? Yeah, do the opposite, right? And so you can like just put it right on top, or you can come down to kind of like the next line underneath, kind of like this, like equation, step of work, equation, step of work, equation, step of work, whatever it is. The whole point in taking the square root, so the square and the square root cancel each other out. So perfect, it's x equals. Now if that was the square root of 4, 2, done. Square root of 9, 3. Square root of 25, 5, right? If it's perfect, take it. Is the square root of 3 nice? So square root of 3 it is. Done. Okay. You don't even have to worry about plus or minus because bases and arguments have to be positive. So we're good. Now I could go crazy and I could make this like x plus 7 or 2x minus 9 or x squared plus 3x minus 2 and like mess with how many x's or what's happening to those x's. And that would just kind of like adjust what we do after. But my focus really for us towards the end of the year and just kind of making sure I touch on a few important things as we wrap stuff up and get out of here. I'm not gonna mess with the x. It's always just gonna be x, whether it's in the argument or in the base. I'm just gonna leave it like that. But it could get tricky. And depending on what you take next year, if you're taking something, whether you're gonna be a senior or whether you're graduating and moving on to something else, logs will come back and you'll see them again and things will kind of increase. So, but it'll be good to have a little bit of that. All right, cool. I want to do a couple more like these, just to kind of give you a chance to try it. I talked through a lot of this. I want you to do more of the talking on this one, but you're gonna see how I'm only gonna erase the things I'm gonna change. The setup stays the same. Call it number 3 and number 4. Let's do pretty similar ones. And then I'm gonna do a number 5 to kind of push us just a little bit further. But let's go, I don't know. We can we'll put the X in the base here. That works for me. It's so cool. So it's a nice way. No, let's go.
5.
5, cool. Sounds good. What should we make it equal to?
7.
7, cool. Looks good. Now let's pick new ones here. I don't want it to be the exact same thing. Log base 4 of x equals 3.
I was gonna say 31.
Nah, too big. Way too big. Let's go 5.
Yeah.
Even 5's pretty big. Bigger the numbers, the crazier the stuff you can get, so we gotta be careful. But you can see it, like the important stuff is still sitting there. I gotta know B and an E. I gotta make a switch. Again, the logs by itself, so I'm good. I don't have to add or subtract, multiply or divide, square root. I don't have to do any of that stuff just to get myself ready to make the switch. The log is isolated on one side. And it's on the side that we like. All right, I know it's kind of tricky when things are switched around. So this one looks good. So here's where you're gonna help me out. Number 3, what's the base? X, cool. What's the n?
7.
Yeah. I was shaking my head to one person. I'm trying to like nod my head to the other. What's that n called again?
An argument.
The argument. Good. And then what's the exponent?
7.
Sweet. Let's focus on this one. Let's just do this one. How do we write an equation that means the exact same thing? Like these are the same. I know it's kind of weird, but these are the same equation, just written differently. If we can do that here, we should be able to break the x out of the log and then do something to get it ready. What is that equation gonna look like, sound like?
X plus 7 equals 5.
Perfect. X base to the exponent equals. It's just not ready yet, right? Because we've got a power still attached to it. We just got to do something with it. You've got x to the 7. We want to get x by itself. What can we do to both sides?
Square root of 7.
7.
Yeah, we need the 7th root, right? Every exponent has its root. It's just that a square root like this isn't strong enough. We just got to put that little 7 right in that little spot right there. Square the square root, cube of the cube root, 7th and the 7th root cancel each other out. So that's good. X equals. Plug this in to see what you get. Do you know how to plug in roots that aren't like square roots? Do you know where to go in your calculator, what to press to see if that's nice? Math folder. Okay, so open it up, clear out whatever you're doing, right? Press math. Now option 4 is dedicated to the cube root. That's the most common one besides the square root. How would we put in a 7th root? Option 5 there, that x root. And what that should do is it should give you a blank spot in what's called the index, the root spot, for you to type the 7. And then you just right arrow in, press the number 5. If it's nice, we'll use it. If it's not, like what we got, right? Point, 0 point, blah, blah, blah. Yeah, no good. So the 7th root of 5 is. Which kind of makes sense. Like, what number to the 7th equals 5? That's really what this question is asking. What number to the 7th equals 5? Well, the 7 and the 7 will cancel each other out. I'm just like, we love the 5, so it's good. And sometimes that's really nice. Like sometimes that's the square root of 9. Okay, sweet, 3, right? Just put it down. But if it's not nice, we know what to do. Okay, cool. Number 4, log base 4 of x equals 5. If this is the first question that I'm going to ask you, this question's shortly thereafter. How do we say things out loud. I want you to be comfortable saying that. So expect that tomorrow. Expect that on Thursday. I'm going to say write in words how to say this log equation out loud so you can be comfortable. And I'm going to leave that up there, right? I'm not going to erase that board at all. So you got to look back at it. All right, cool. What's our base for number 4? 4. Argument. There's what I'm looking for, okay? And then the exponent. Of course, the only thing left over. And the reason we can make that, we can write down b, n, and e is because the log by itself. You'll see once we do number 5, we got some moving stuff around. All right, cool. So what's our new equation look like?
4 to the 5th equals x.
And look, the x is by itself. I'm good. I'm ready. I just got to figure out whatever 4 to the 5th is. Now, that's not 20, right? It's not 4 times 5. It's 4 times 4 times 4 times 4 times 4.
1024.
There you go, 1024. You did that in your head, obviously, right?
Oh, yeah.
1024. These numbers get really big real quick. Jump in your calculator, 4 to the power of 5, press enter. I will make sure that our numbers stay within a reasonable size so we don't get like scientific notation. So, but that's, look at that. Caden, imagine if you made that thing equal to 31. That'd be 4 to the 31st.
45,361.
4 to the 31st is bigger than that.
That would be like,
4 to the power of 31.
like a
That's 4 times 4 times 4 times 4 times 4 times 4 times 4. 31 times. This is 4 to the 5th. You got to multiply it 26 more times. It's probably so big, it's going to say like, it's going to have a decimal and then like E something.
Yeah, it does.
So what is it? I'm just curious. So 4 to the 31st is approximately, what'd you get?
4.611686018 E18.
Times 10 to the 18th. That's 4. And then 18 more numbers. 611, and then all those decimals, right? Whatever they are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Million, billion, trillion, quadrillion, quintillion.
Wow.
Over 4.5 quintillion. Okay, that's more atoms in the universe. There's less atoms in the universe than
How
that
many
number.
atoms are in the universe?
Crazy.
How many atoms are in the universe?
In the quadrillions.
How do we know that? Like,
Yeah.
We don't know for sure,
It's
but
just
we
like-
have a lot of educated guesses going in there. Yeah.
How many atoms?
It's about like its density of planets around stars. So we know about how many stars there are in our galaxy. We know about how many galaxies there are in our supercluster. We know how many superclusters there are in the universe. So we just multiply those things together. Now, of course, we don't know. We don't know for sure. But there are, as far as we know, over 10 million inhabitable planets in the universe. Over 10 million inhabitable planets. Okay, we're one of those.
Did you see Elon Musk apparently there's going to be a Mars mission soon?
Really?
And like apparently said like tons of people there's going to be bombed. Yeah.
It takes 2 years just to get there.
I thought it was 5.
Is it?
Yeah.
Well, yeah, 2 years because we're just sending robots, right? If we have people, we got to slow down. We can't go too fast.
Yeah, that's what they're doing.
Crazy, right?
Well, they're trying to make it like we can live on Mars or like Earth, like it's too.
That's a one-way trip.
I
Trip to
was-
Mars is a one-way trip.
I was
So
watching an interview with him, and he was like, a way to make it like habitable is like you nuke it. You have to nuke it. So like.
there's no atmosphere. That's the problem, right? Gravity is, I think it's similar though. I don't think it's like the moon where it's like 0.6 gravity, right? You weigh like, if you're 100 pounds, now you weigh 60 pounds, that kind of thing.
Isn't that like crazy on Jupiter or something? We were like 3 times as long on Jupiter or something.
Yeah, because Jupiter is so massive, right? Gravity has to do with the mass of the object that you're on, because when we put a big object into space, which we kind of think of as kind of like a net, right? Put a big object in the middle of that, and what happens is like the space begins to bend around it. And we create, like, imagine like, stand up, stand up. Hold up those 2 ends. Here, come hold these 2. Okay, this is space right now.
I'm pretty sure.
Take a very light object and put it in, and not much happens, right? That the space does not bend with it, okay? Take a
Oh.
heavier object
Ah.
and space bends around it. And the gravity is heading towards the middle of that.
Is that how all of space works?
Well, that's what we understand, is that gravity is not necessarily a force pulling you in to the center of something. It is bending the space around it, and you're falling into the center.
Like, I could imagine, so like, you know, if like you're driving on an interstate, like through Wyoming, and like you see how the road is black and you see all the like heat waves, kind of?
Yeah, that's an optical illusion.
Well, that's where it's like, where it looks
The
like a light.
mirage, yeah,
That's in
I feel like it would look like that.
right. I don't know, like, so like light comes off a star in straight lines, right? So light moves in a straight line, but also moves in waves, which is crazy. But what's going to happen is the light is going to bend around heavy objects because the space around it bends. And so when I observe a star behind a massive planet like Jupiter, even though I can't literally see where it's coming from, what's happening is because the light is bending around it, it makes it look like it's over there. And think about this, right? We're talking about lights that are hundreds of millions of light years away. If you can see that, that means there was nothing in between you and that light. And you're looking at something from hundreds of millions of years ago. You were looking that far into the past, which I think is really cool. Like you look at the sun, you're seeing something 8.5 minutes ago. That's how long it takes the light to get from the sun to your eyes, 8.5 minutes. When you look at the stars at night, you are looking into the past, which is so cool. Yeah.
Does this mean that like the little dipper and the big dipper are actually are now? Like,
Oh, yeah.
let's see.
Oh, every star, everything in the universe has a lifespan, for sure. The reality, though, is that our star, the sun, has about 3 billion more years left. So I think we're good. But there's only so much energy. I don't know if you've heard this in your science classes, but matter and energy are never really gained or lost in the universe. It's a zero-sum game. If you gain energy over here, I have to lose energy over there. Same thing with heat, right? Heat is not really gained or lost, it's exchanged between atoms. And temperature is really just how fast the electrons are moving around the atom. Okay, the faster they move, the hotter the object. And so what happens when you heat things up, you are heating up the electrons. They are moving faster around the outside. So cool. All right, let's do one more, and then I'll give you a couple to try, and then we'll get out of here. Call this one number 5. I'm gonna mess with the log now. 2 times log base 3 of x plus 4 equals 12. Just made it up. This should work out okay. 2 times, and I like to put that dot there as a super clear reminder that it is multiplication, but I don't need to. I could just say 2 log base 3 of x, but I like the dot. And I can't say like the base is 3, the argument is x, and the x1 is 12, because what about the 2 and the 4? Right? We have to get the log by itself first. And if we can do that, just like we always have, to isolate whatever we're trying to get by itself, then we're good and we can make the switch. So if you're given something like this, right, variables stuck in a log, right, I gotta get to exponents eventually, because that's the only way to solve them. Let's get that log base 3 by itself. Of course, with the x, right? Log base 3 of x, let's get that by itself. Then we can make the switch. So what do you think? What should we do first? Kind of start moving some stuff around. -4. Yeah, right? Just like we always have. Oh, I got +4. Let me do the opposite. -4 on both sides. Those will cancel out there. I didn't touch any of this. I'll just bring this down. 2 times log base 3 of x equals 12 minus 4 is 8.
Divided by 2.
Yeah, right, because we're still not alone yet, right? I still have that 2 sitting down front, so let's divide by 2, divide by 2. Those 2's will cancel out. Nothing I can do here, though. That 3 stuck in the base. I can't, like, call that 1.5. This x stuck in the argument. I can't call that, like, x over 2. We're good. I'm just going to say, okay, cool. Log base 3 of x equals 8 divided by 2 is 4. Now, this problem looks like 1 through 4. If we can get it to look like those, then we can make the switch. If you like to do this, right? B equals, N equals, E equals, now's the time. Couldn't do it before. Now, the base and the argument don't change. Those have been and will always be in this problem, 3 and x. It's just that our exponent wasn't 12, right? It was 2 times something plus 4. It was just too big. So we had to shrink it down. Now it's 4. I'm going to just come over here so I can keep rolling through. All right, now we make the switch back to Ben from log to Ben A. And the x is by itself, which is nice, right? We got kind of lucky that the x was the argument, which kind of isolates that over there. Sorry, it's a little faded. So I don't have any like solving to do. I don't have to like now add, subtract, multiply, divide. I just have to figure out what 3 to the 4th is. It's not 12, right? 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, times 1 more, total of 81. There we go. And again, I could go a whole bunch crazier with these and kind of mess with the base or mess with the exponent or like make it equal to 1/2 and oh, it's power over root and get all crazy. But we're going to keep it simple. This will be the last week where we solve any log equations, and we'll figure out what we want to do next week. Seniors, next week, you won't learn anything new. We'll probably review Monday, Tuesday, maybe even Wednesday, and then test on Thursday. Depends on how long I want to make it. It's going to be multiple choice. It'll be on Canvas. You know, you can use all your notes. You can make a note card, whatever is easiest for you guys, whatever you decide you want to do. So, but I'm going to send an email out or a message on Canvas probably today or tomorrow, just to kind of break down what I'm thinking and kind of get your perspective. All right, cool. We got 15. So I'll put up like, I don't know, like 4 or 5 or something like that, just to kind of get you some more practice to have down so you can look back at it tomorrow and then approach it. All right, questions? How are we feeling? We doing okay? Stuff sinking in? I know it's not like what the hell are logs for, right? I get it. That's why we're going to keep it short and sweet and then switch it up a little bit. So we've got some freedom, like I said, to do whatever we want. I've been saying this all year, right? This is our class. We can study whatever we want. So I'll look at what I think is most important kind of going into the next year or the year after. Let me see if I can find a better marker. I wonder if this purple one's any better. That's not too bad. Let's go 1, 2, 3, 4. We got 15. We'll do 5 and 6. How about 6?
Are we going to be submitting it?
No, this is just for you. Yeah, this is just for you guys. All right, number 1, log base 2 of x equals 3. Log base x of 9 equals 2. That looks good. Log base x of 8 equals 5. Log base, oh, I know what I'll do next week. Yeah. Log base 7 of x equals 3. All right, let's get some multiplication going. 3 times log base 5 of x plus 2 equals 11. And 2 times log base x of 4 minus 6 equals, I don't know, 2. Sure. All right, give those a shot. In about a minute, I'll write down the answers to the first couple. And sure. Every couple minutes after that, I'll keep jotting some stuff down for you. Hopefully that helps you out. Sure. Go, just go now. Yeah. This way you can come back and finish up.
Yeah, my ear just started bleeding.
Were you like picking at it or something?
No, it's like itching my eye. I don't know if she looks at me because I'm bleeding.
Go take care of it. Yeah. I got Band-Aids in case you need anything. Yikes. All right, that one's good. Salud. So we're in like 4.7, I guess. Because that was all exponential stuff. It's solving exponentials. We want to solve log equations. So I might call it. I don't know. Let's call it 4.7, and we'll solve log and exponential. Solving log, exponential, log equations. What's today? Tuesday? Right, so Wednesday or Wednesday. Make it out of like 30. We'll see if I adjust that. What we do tomorrow. Is 4.7. Make that out of like 50. Maybe we'll push that to Friday. Let's say Thursday for now. Sweet. All right, let me get some answers down for those first couple. You're getting those right, you get it. For sure. Move these to the top. I wish I could fix that. So, here we go. Answers to the first couple. Ooh, geez. No way to go with that number is 7 to the 3rd. But no, let's ask. Let's see if I can think about it. So 7 times 7, 49. Times 7 again. 9 times 7 is 60. I can't do this one. I'm so stuck. 49 times 7 is going to end in a 3.
How was your ear bleeding?
I don't know. Still bleeding, but like whatever.
Do you want a Band-Aid?
No, I put a Band-Aid on my ear.
Where is it?
It's like on the back of my ear. And it's like black. Let's look at it.
It's not bleeding though.
It was. Look at it.
We can put a little one on there.
How'd you even notice it?
I heard it. I was going like this.
You heard what?
I heard it pop.
Oh, because it kind of looks like a pocket of blood or something, like
Yeah.
it was like bleeding a little bit on the inside, but never really open. That happens sometimes.
I never put an earring back in there.
Or like your ear could have stabbed it, you didn't know it was bleeding, so you just tried to. Don't touch my leg, I will seriously.
I was gonna say,
No, it's
assistant
fine.
doctor.
It's fine.
Yeah.
Then I'll just be like, yo, what's up? No, it's you, what's up? And I'm like, what's up? Do a handshake, we go get a few drinks. With love.
You gave her the house room and you're like, are you hungry? And I was like, no. And he was like, are you sure you don't want to go and watch it dead? And I'm like, yeah, I'm hungry. And he was like, well, I'm going to food. And I was like, why are you never here? And he was like, because Katie's out of town. There we go. There we go. Yeah. All good. Because that was the day after you were, yeah, thanks, everything.
You're welcome.
What did he say?
You too.
All right, my brain doesn't work. I'm gonna let. Okay, do it 7 to the 3rd. Yeah, I was right. Ended in a 3. 3 to the 3. Getting short on time, so I'll just do it. -2 divided by 3, 5 to the 3rd is 1.5. 8, 4, x to the 4 equals 4.
You're feeling I could tell a guy to be a sword fighter, right? And I grab the blade,
No, you're not correct. You.
and then he just slides it out of my hand like
That's
it's
so
nice.
rude.
Then I asked Mr. Rosie for a Band-Aid.
I got you, Cole.
Mr. Rose.
I got you, Cole.
Do you have crystals on your keychains?
Yeah.
Yeah.
You're a witch, man.
What? It's
Crystals are
literally,
weird.
no, some girl made them.
No, not you, her. She has crystals on her keychains. Like literal crystals.
Yeah. They're from Five Below, so they're not actually real.
They're my nude crystals.
Oh, it's from Five Below?
I can tell I have a positive vibe right now.
Everybody's trying to touch their stuff, they like the rappers, like all of them. Really? Yeah. It's so much up. Cole's probably a thief.
Yeah, I steal crystals from Five Below.
What'd you do, Bryce?
I haven't stolen anything yet.
Are they actual?
Do they like mount up cameras or something? No, just everything's like little trinkets. Oh, okay. And we just go smash some stuff. Yeah. I mean, Kennedy works there, so like, oh, okay.
And they're
Yeah.
like little.
What are they gonna sell there?
Just a bunch of random.
It's actually pretty sick. Oh, is it like everything under $5? Yeah. Oh, that makes, I thought it was like a. Yeah, one store. No, it's actually pretty nice.
Does anybody care about the cuteness of my kids? Because I.
Yes.
Yes, how many more?
My daycare lady always sends us pictures.
Oh, that's what I do when I leave.
They would love that.
No, look
They're
at.
a little blurry on that one. Got a shirt that says this snuggle is real.
I can't read it.
My daughter, her first dentist appointment.
Oh,
How'd you like it?
She loved it. No, she loved it.
So you're going to Disney?
No, we've been. I'm not the kind of parent that like lies to my kid about what we're doing and then all of a sudden we're someplace else.
My mom does that to me. I wanted to get ice cream the other day. She took me to the chiropractor. Hey, but you need it to get the chiropractor.
But we got her like a dentist, like playset, and a doctor playset, and like she wants to be a doctor.
That's lucky for you.
I know, right? She's smart as hell, so hopefully she needs a free ride because I ain't paying for it. $500,000.
Is she gonna play sports?
Yeah, I think
I think she's gonna be quick, so she'll probably play like soccer, softball, run track, stuff like that.
Are you gonna coach her?
No, I'd much rather be the dad on the sidelines that actually just to watch. Like I'll be coaching like baseball probably stuff. I might eventually coach my son in baseball if he wants to play it. I don't know. I might coach him.
Just wait, man. All of your sons, like teammates, you're gonna like your daughter. Once she's like,
So she's gonna be tougher than all of them though. So she's gonna get hit on. Just like, what'd you say? Knock her out. She's tough, strong. She's like
big shoulders.
big. Yeah, she's like stacky and strong. Yeah. Like, and she pushes my son around like crazy, so he's gonna be tough too.
Wow. That's how you
Ow.
Easy.
He literally calls me like.
There are no bells today, right?
No bells, yeah. So we are good to go. I will see you all tomorrow.
Have a good one.
Thanks, everybody. See ya.
Tomorrow.
Sounds good, Liam. Thanks, buddy.
We had like a 500.
Yeah. Yeah. Thanks.
So give 'em